Have you ever wondered how scientists know that global sea levels are changing, even with all the daily ebb and flow of tides and weather? It can seem like a monumental task, deciphering subtle shifts amidst constant motion. Well, the core answer lies with specialized instruments called tide gauges. These devices continuously measure the height of the sea surface relative to a fixed point on land. By collecting and meticulously analyzing decades of this consistent, local data, scientists can accurately detect long-term sea level trends, distinguishing between localized land movement and changes in the overall volume of the ocean. The reason this long-term perspective is so crucial is because the ocean's surface is incredibly dynamic. Short-term factors like daily tides, wind, atmospheric pressure, and even seasonal ocean currents, such as the El Niño Southern Oscillation, can cause significant temporary variations in water levels. A tide gauge needs to operate for many years, often for more than 19 years, to average out these natural cycles and reveal the underlying persistent trend. To extract these precise long-term trends, scientists meticulously collect data from tide gauges situated around the world. They then apply sophisticated data processing techniques. A critical step involves accounting for vertical land motion, which is whether the land itself is rising or sinking. This is often done by integrating tide gauge data with measurements from global positioning system receivers and other geodetic techniques like very long baseline interferometry. These corrections allow scientists to calculate an absolute sea level change, rather than just the relative change between land and sea. This powerful combination helps distinguish between relative sea level, which is what the tide gauge directly measures at a specific location, and absolute sea level, which refers to the actual height of the ocean's surface in relation to the center of the Earth. Organizations like the Permanent Service for Mean Sea Level, or PSMSL, play a vital role by maintaining global archives of tide gauge data, some stretching back over a century. These extensive, consistent datasets are invaluable for studying past climate variability. Ultimately, the dedicated work of monitoring and analyzing tide gauge data provides us with an indispensable record of our changing planet. It forms a fundamental cornerstone in our understanding of climate change impacts, guiding critical decisions for coastal communities, infrastructure planning, and environmental protection around the globe. This careful, persistent measurement helps us prepare for tomorrow.